Welcome to the session. So in this session, we will discuss some other basic terms that are to be known in thermodynamic subject. So next one is state. State is nothing but it is the characteristic of the matter at different property value. That means while explaining a property in the previous lecture, I have told you a state can be only explained when you know the property value. For example, if you take water H2O, it will be in liquid form, then the pressure is at 1 bar and the temperature will be in between 0 to 100 degrees. If at the same pressure, if temperature is more than 100 degrees, it will be in gaseous form, and if the temperature is at below 0 degrees, it will be in solid form. If the pressure changes, then the boiling point and freezing point automatically changes. Likewise, the state of anything can only be explained at definite property value. So, for example, consider a system which is not undergoing any change at this point. All the properties can be measured or calculated throughout the system, which gives us a set of properties that completely describe the condition or the state of the system. At a given state, all the properties of a system have fixed values. If the value of even one property changes, the state will change to a different one. This can be shown in the figure. In state 1, the mass is 2 kg and temperature is 20 degrees Celsius and the volume is 1.5 meter cube. If it expands, then the mass will be in 2 kgs, temperature will be 20 degrees Celsius, but volume changes and the state will obviously change. So any matter can exist in all these three types. That is solid, for example, water. If you take the solid is ice, and liquid, the liquid will be in water, and the gas, which will take it as steam. So for any material, there exists all these three values. Next, process. The next concept is process. Any change that a system undergoes from one equilibrium state to another is called as a process. And the series of states through which a system passes during a process is called the path of the process. For example, if you take an example of ice, if you supply heat to that ice, then ice will be converted into water. The states between these two is solid state to liquid state. And the process that undergone by that H2O, that ice is called as process, and the path followed is called process path. Next one is a cycle. This term is very much important because we will discuss many other cycles which will be basic for many engines and power plants and everything. So a cycle can be defined as a system is said to have undergone a cycle if it returns to its initial state at the end of the process. That is, for a cycle, the initial and final states are identical. You can see that in this PV diagram. From state 1 to state 2, if it follows path A and if it follows path B from state 2 to state 1, but it retains its original position at the end of the process, then this is called as a cycle. For example, again, if you take example of water, if you supply heat to the water, then what happens? It will be initially it will be at state 1, that is liquid state. Then it will be converted into gaseous state. And if you again cool it, then it gets condensed and it will be converted into liquid state again. And that is called, the complete process is called as cycle. In order to describe a process completely, it is mandatory to specify the initial and final states of the process and the path if followed. Next one is very important concept, quasi-static process. So here quasi means almost and static means no motion. So quasi-static means almost no motion process, which can be taken as very slow process. In thermodynamics, for studying, we'll take everything as a quasi-static process. That why we should take everything as quasi-static process, we can explain from this example. Let us consider a cylinder and a piston arrangement, where the piston is balanced by a weight from the force from the gas inside that cylinder, and the gas will have pressure P1 and volume V1 and T and temperature T1. So this can be taken as initial state. Here W, the weight will balance the force exerted by this gas on the piston, and that's why it will not have any movement. So it will be in static position. And if the weight is removed, then what happens? Because of the force from this force exerted by the gas, the piston moves upward and it will be stopped at stops. Then the pressure will be changed to P2, V2, T2. By using these values, if you want to draw a PV diagram, you can mark P1 value, P1 V1 value, and P2 V2 value. And then you don't know which path it has followed. The path might be this, or the path might be this, or this. The path might change to anything. The path must not be this only. The path might be this also. The path might be this also. That's why we don't know the path followed between these 2 points. So for the same experiment, if you for the same experiment, you can do like this also. The weight is divided into 5 small weights. That means in the previous thing, the W, if the W is weight, that is, let us take an example of 10 kg. The 10 kg is divided into 5 2 kg plates. Then this experiment, the same experiment can be performed like this by removing each and every plate. When removing one plate, you have to note the pressure and volume values. Likewise, for every removal of plate, you will note the pressure and volume values, and you will get final values. Then, between 1 and 2, when you draw that in PV diagram, between 1 and 2, you will get nearly 5 to 6 points where there will be a definite path which is followed by that. And each point in this graph is an equilibrium state, and this process is slow process than the previous one. That's why you can know the path followed by it, and you can calculate the process, the work done in that process. That's why quasi-static process is very much important in view of thermodynamics. And our next concept is point and path functions. Before going into it, you must know what is meant by a function. A function is nothing but a property value or which will give you an idea about the process or the system. Here it is divided into path function and point function. The path function is their magnitudes depend on the path followed during a process as well as the end states. Example, work and heat transfer. For calculating work and heat transfer, you must know the initial state and the final state, also the process followed by it. In the example or in this graph, you can observe the initial state is 1 and final state is 2. And if you want to calculate work done, you must know the graph under this 1 and 2. So if you take this as 1 and 2, see as the process followed, you can observe this. You can observe the area under 1 and 2 when C is followed is lesser than the area under 1 and 2 when B is followed, and area under 1 and 2 when A is followed. So it is very much clear that it completely depends on the process it followed. So the work done will change if the process changes, if the path changes. So that's why work done and heat transfer are called as path functions. Next one is point functions. They depend on the state only and not on how a system reaches that state. All the properties are point functions. Because if you want to know the volume at some instance, you can directly calculate that volume. You need not to know the path it follows. That's why these functions are point functions. Example is all the properties like volume, density, temperature, pressure, everything. So heat and work are not properties of the system. As they are path functions, they cannot be taken as properties of the function. And for calibrating or evaluating them, you must know the path followed by it or the process it undergoes. Next one is work. Work is nothing but when a force is applied for the displacement of matter, then the work is said to be done. That is W is equal to force into displacement. When it is done by the system, it can be taken as positive and it is taken as negative when it is done on the system. So W is equal to force into displacement. Force is nothing but pressure into area. That's why W is equal to P into A into the displacement will be change in length, which is dl. So here area into change in length will give you change in volume. So dW is equal to PdV. Applying boundary conditions, W122 is equal to P into V2 minus P1. Next concept is heat transfer. The energy interaction between system and surrounding due to temperature difference is called heat transfer. When there is a difference between temperature in the surroundings and system, then only the heat transfer will take place. For example, if there is some hot body and a cold body, if you join both, because of the temperature difference between that hot body and cold body, the heat will transfer from hot body to cold body until it attains equilibrium state. That means until it attains same temperature level. So this heat transfer will be in three modes. One is conduction, another one is convection, another one is radiation. Conduction is a mode of heat transfer which will be mostly in solids where there will not be any molecular interaction, but the heat will transfer because of the molecular vibrations. You can take an example of a spoon which is heated from other side. If you are holding, for example, if you are holding a spoon with one hand and the other side of the spoon is heated, then after some time the heat transfers from hotter side to colder side without any movement of molecules inside the spoon. This heat transfer will be done by the molecular vibrations. And hence, without movement of molecules, if heat is transferred in the solids, then that mode is called conduction. Coming to in fluids, when heat is supplied to fluids, they'll get excited and the molecules will move. While moving, they'll transfer that heat to the molecules which are in less temperature. And this process is called convection. That's why convection is the mode of heat transfer which will occur in fluids. Also, while mixing of hot fluid and cold fluid, the convection takes place. For example, you take hot water, when you are mixing it with cold water, the molecules in the hot water will transfer the heat to the molecules in the cold water. And after some time, both will be at same temperature or equilibrium state, then heat transfer stops. And this type of heat transfer is called convection. And the last one is radiation, which do not need any medium, which do not need any contact. The best example is getting heat from sun. The heat from sun travels through vacuum and then our atmosphere and then it will touch our earth. So it is very much clear that for that transfer it does not need any contact or any medium, and that type of heat transfer is called radiation.